We're going to be combining these roots, and the first thing I notice is the radicans are different, so we're going to try to simplify each root individually and see if the radicans match so that we can actually combine this. So for this first root, I have 5 times the third root of 125. I know I could take the third root of 125, and if I couldn't, I would actually make a factor tree of 125 and write the prime factors inside. So a to the 7th, I'm going to expand that. So a times a times a times a, that's 4 of them, and then we need 3 more. So that's a to the 7th, and then b squared, so I'm expanding. So the reason I did that was so that I can look for groups of 3. So the reason I know I'm looking for groups of 3 for my expansion of my a's and b's is because we're taking the third root. So let's simplify this. The third root of 125, again, is a whole number. Really, you're saying what odd number can you multiply by itself 3 times to get 125, and the answer is 5. So right now on the outside, there's a 5 there, and because the third root of 125 is 5, whatever I bring to the outside, I'm going to be multiplying it with the 5 that's already there. So that takes care of the 125. If I look at my expansion of my a's, I'm circling groups of 3 because, again, it's the third root. How many groups of 3 can I circle? 2 of them. So I'm bringing a squared outside, and the reason it's a squared is because there were 2 groups that I could circle. In terms of the b's, I can't circle a group of 3. So what's left inside the third root symbol, I have an a, right? This a here, and then I have b squared. So a times b squared is left over. All right, let's simplify the next root, okay? So I have 2a, open up the third root. I know I can take the third root of 64. That's going to be a whole number. So I'm going to expand a to the 4th and then b squared. So let's start with the third root of 64. So that's going to be a whole number. What even number can you multiply by itself 3 times to get 64? And the answer is 4. So on the outside, I have a 2 and an a there, right? So I have 2a times the third root of 64 is 4, so I'm bringing out a 4. So that takes care of that part. How many groups of 3 can I circle for the a's? 1 group of 3, so I'm bringing out 1a. How many groups of 3 can I circle for the b's? None. So that's the only part that's going to go outside. So I'm going to open up the third root symbol. What's left inside, I have an a and then a b to the 2nd power. So if I take a look now at my insides, I have a b squared and a b squared. So that means I can actually combine these. So the root here, I'm going to rewrite that root, the third root of a b squared. And my final answer, I just need to figure out how many of those I have. What's the number in the front? So to do that, I need to combine this part and combine this part and add them together. So 5 times 5, 25a squared, and then 2 times a times 4 times a is 8a squared. So all I'm doing is combining those by adding those together. So 25a squared plus 8a squared is a total of 33a squared. So 33a squared. This would be my final answer.